North Carolina has the largest area of shallow coastline along the East Coast, and that offers the potential for a bright energy future.
A shallow coast is a good thing because currently a lot of the technologies for structures basically require less than 100-meter water depth.
But there are many questions surrounding marine hydrokinetic energy. That's the renewable energy found in the movement of waves and currents. So researchers are conducting multiple experiments to answer some basic questions. Just how much renewable energy can be harnessed in the ocean? What types of structures would be needed? And how difficult and expensive will it be to build those structures?
We can do that. Still, we're engineers. We can make it stand up. We can build it so it stays in place. That's a challenge, but not an impossibility. And with every challenge comes an expense. And the expense is not going to be trivial.
The University of North Carolina Coastal Studies Institute is working with the engineering programs at North Carolina State University, the University of North Carolina at Charlotte, and North Carolina A&T University to answer those ocean energy questions. Researchers are focusing on three types of ocean energy: currents, waves, and wind.
Because if you go put something like a turbine in the water column, then the Gulf Stream will be there much of the time, we hope.
Mike Mulia is studying one of the more unique energy ideas. He believes some of the state's energy future could be found in about 800 feet of water, roughly 10 miles off Cape Hatteras, by placing giant turbines in the Gulf Stream.
It's moving, it's moving about 4 knots, so that's nautical miles an hour, so it's about 4 or 5 miles an hour.
That doesn't sound very fast.
The energy you get from a moving fluid, like with a wind turbine, is proportional to the density. And so, since the density of the water is 1,000 times greater than that of air, it's about 1-to-1 with what you would get from the wind if you went and put a turbine in the Gulf Stream.
Scientists are combining data from land-based radar, which measures surface currents, with satellite images measuring water temperature to pinpoint the Gulf Stream, which studies are showing is the largest and most consistent form of ocean energy.
And what this does is it sits on the bottom for a long period of time at what we think is an optimal location. And it measures the current from near the bottom to near the surface. So if you imagine, this is the instrument. This is called an acoustic Doppler current profiler. And it's like kind of like 4 fish finders if you're a fisherman. And it sends out sound waves throughout the water column at a specific frequency. And as the water moves past the sound waves, the particles in the water reflect the sound back to the instrument, and they Doppler shift the frequency that we emitted. So from the amount that the sound waves are Doppler shifted, we can determine how fast the water's moving.
Next comes wave energy. It's not as consistent as the Gulf Stream. Waves can be large and small, but
Wave energy is probably as good on our portion of the coastline as any place on the East Coast.
So researchers are exploring wave energy conversion. This is a surge device. It's made by Resolute Marine Energy.
A paddle that would be anchored to the bottom and able to flap back and forth as the waves came by, with the top of the structure being very close to the water level. And so as the wave came by, it would move back and forth, and that movement would then drive a little turbine that would allow the power takeoff to generate electricity.
The initial findings from 2 experiments with surge devices show, depending on the coastline and the conditions, wave energy is very efficient. It generated roughly 10 kilowatts of energy per meter. That's enough energy to power about 3 houses. And that leaves wind power, probably the best known form of renewable ocean energy. But there's one big problem.
Nobody wants to look out at the pristine ocean landscape and see a number of turbines standing up in the waters offshore that would be facing the direction that you're going to see the sun come up or the sun set.
That means wind turbines must be located far offshore. That makes it more difficult to get the power that is generated back to shore. It also means wind farm turbines must be strong enough to survive hurricane-force winds and waves.
Anything we do in the ocean is going to be a lot different in terms of foundations, in terms of the external environmental forces, the impact of how we would connect something in the ocean to the grid.
Because there are so many engineering challenges, researchers say it could be almost a decade before ocean energy is able to be tapped. In addition, there are also environmental challenges, which must be overcome.
So threatened and endangered species, protected species like marine mammals, and then protected habitat are many of the environmental concerns. And then as far as human use concerns, we have a commercial fishing industry that is that also has a component that's sport fishing here in North Carolina, and then we also have a huge dive community here. So making sure that there aren't too many conflicts between those existing uses of the coastal ocean and ocean-based energy.